Yes, we are going to continue with the exercises here. Write down the following expression as single logarithm to base 3. Here all the expressions, they're related, the base related with 3. Here is, if you see, this is 9, this is 3 squared, and this is 3 to root 3. Root 3, if you remember, it's equal to 3 to the power of 1 over 2 it's going to be. Okay, and 3 to the power of, if you remember, 1 over 3 is going to be equal to 3 to the power of minus 1. So we are going to write all these terms, all these bases in terms of 3. So this expression is going to be equal to logarithm base 3 to the power of minus 1, 7 plus 2 times logarithm base 3 square 49 minus logarithm base 3 to the power of 1 over 2 1 over 7 is going to be. Okay, if I get this powers in front of the logarithm, if you remember, logarithm base, if you remember, logarithm base a to the power of n, b to the power of m, it was equal to m over n. This power comes to denominator times logarithm base a, b. So I'm going to write this n to denominator, this powers to denominator. Here the numerator is 1, that's why it's going to be equal to 1 over minus 1. It is not written here 1, but we know that's 1. Logarithm base 3, 7 here, and plus 2 times 2 over 2, this 2 comes to denominator, times logarithm 3, 49 minus 1 over 3 times logarithm base 3 1 over 7 it's going to be. Okay, 1 over minus 1, it's going to be equal to minus. So this is minus logarithm base 3 7. This is plus logarithm base 3 49. And 2 over 2 is equal to 1 because here this one and this one, when you simplify, 1 and 1 we have. And here this is going to be 1 over 3. We are going to replace here the terms, and it's going to be equal to 3 times logarithm 3 over 1 normally. 1 over 3 becomes 3 over 1 times logarithm 3 1 over 7. Okay, then it's going to be equal to logarithm minus logarithm 3 7 plus logarithm 3 49. This is minus 3 over 1, it's going to be minus 3. But if you remember, for addition and subtraction operation, in front of the logarithm sign there shouldn't be any coefficient. So this coefficient should come as a power of 1 over 7. So we can do like this: minus logarithm 3 to the power of 7 to the power of minus 1 to the power of 3. 1 over 7 is equal to 7 to the power of minus 3. It's going to be. Okay, this is equal to, now in front of the logarithms there is no sign. When it is minus coefficient, there is no coefficient, and the signs are here minus and minus. So we are going to write logarithm base 3. When the sign is minus, that main part is written to denominator 7 times here 7 to the power of minus 3, and here it's going to be equal to 7 to the power of 2. And if we write all the terms to one side, 7 to the power of logarithm base 3, 7 to the power of 2 minus, here it is 1 minus 3, that's going to be equal to 2 minus 1 is equal to 1 minus 3, it's going to be plus 4, so plus 3, 1 plus 3 is equal to 4. Logarithm base 3, 7 to the power of 4 is going to be, and we have written as single base 3 logarithm this expression, single base 3 logarithm. As the end result is not 5 or 4 or 3, but single logarithmic base we have here, and logarithm base 3, 7 to the power of 4 is the answer. Here, this was the property. Logarithm base AB is equal to 1 over logarithm base BA. Main part and logarithmic base, they are going to change their places. We are going to switch them. So logarithm base 8, 7, it should be equal to 1 over logarithm base 7, 8. Or base 8, 6, it's going to be equal to 1 over logarithm base 6, 8. We are going to replace them. Pardon. Yes. About the question, about the property, we are going to solve this question. Here, the bases are not same. Normally 2 and 12, and here logarithm base 3 and 12. Bases are not same, so you cannot do any operation. It seems like that, but this expression normally it's equal to 4 times 1 over logarithm base 2, 12 it is, and plus here 2 times 1 over logarithm base 3, 12 it is. Here main parts are same and it's written as 1 over form. So if I use this property, you know this property, 1 over logarithm base BA is equal to logarithm AB. So I'm going to replace this main part and the logarithmic base, and it's going to be equal to 4 times logarithm base 12 2 plus logarithm base 12 3. I changed the logarithmic base here, and pardon, 2 times here it should be. And if you want to do any addition operation between the logarithmic expressions, you need to send the powers back, or the coefficients of the logarithm as a power of the main part. Logarithm base 12 2 to the power of 4 plus logarithm base 12 3 to the power of 2 is going to be, okay, 2 to the power of 4 is equal to 16. Logarithm base 12 16 plus logarithm base 12 9 it's going to be. The answer is logarithm base 12 16 times 9, that's equal to logarithm base 12. 16 times 9 is equal to 144 it's going to be, and that's going to be equal to logarithm base 12 square, and this 2 can be written as the coefficient of logarithmic part, and it becomes 2 times logarithm base 12. This expression is equal to 1. The answer is 2. Okay. Here we can write under the common base. This property shows that one. We want to choose another base for them, like logarithm base C B and logarithm base C A. The main part goes to numerator, and here logarithmic base comes to denominator, but there they become main part, or argument we are calling. Here the example 3 and 8, logarithm 5 the base chosen, logarithm base 5 8 and logarithm base 5 3. So we change the base to 5. If we want, we can do this operation. And if here the base is 9, but I want to change it to 6 for some reasons. Maybe we are going to see in the examples why we are going to change them. And here logarithm base 6 8 over logarithm base 6 9. The denominator should be the logarithmic base, numerator should be the main part of the logarithm. Okay. Logarithm base, we are going to use this one here. Logarithm base 5 2 is equal to p, and write this one in terms of p, it says, and the base is 5. So I need to change the base here to 5. How can I do this one? Logarithm base 20 200, I need to change the base 5. So logarithm base 5 and logarithm base 5, I'm going to replace like this. And when I change this base to base 5, the 20, what is written denominator, it should be as a base, it should be denominator. As a main part, what is written, that should be the main part of the numerator. Now I apply the rule here. Okay, then if it is like that, logarithm base 520, logarithm base 5 200 it's going to be, and I'm going to write 220 in terms of 5. This can be equal to 5 times 5 times 2 times and 2. Yes, 200 is like that, and 20 is equal to 2 times 5, so it's equal to 2 cube 5 square 2 square 5 it should be. Okay, why I separate like this? 200 as 5 square and 2 cube, because here logarithm base 5 2, it is given p, so I need to separate in 2 and 5. 5 is going to be 1. When you see the operation, you are going to understand. Logarithm base 5 2 cube times 5 square, the operation between them, multiplication, over logarithm base 5 2 square times 5, then is going to be equal to logarithm base 5 2 cube plus logarithm base 5 square. Here there was a multiplication inside the main part. I separate them and it becomes like this, over logarithm base 5 2 square plus logarithm base 5. Here this powers can be written in front of the logarithmic base, and it will be equal to 2 times logarithm base 5 2 plus 2 times logarithm base 5 which is equal to 1, and pardon, this is going to be 3. This is going to be 3 times logarithm, and over 2 times logarithm base 5 2 plus here directly it's going to be equal to 1. Okay, then it's going to be logarithm base 5 2, it is given in the question p, so the answer is 3p plus 2 times 1 is equal to 2 over 2 times p, again 2p plus 1 logarithm 20 200 in terms of p is written like this. So this is equal to logarithm base 20 200. Okay, here we are going to write each logarithm in terms of logarithm base c. Here logarithm base c, it means that we are going to choose the logarithm base a, we are going to choose, pardon, because c is equal to logarithm base ab. Express each logarithm in terms of c. So the base, if it is a, I'm going to for the a, logarithm base a square b and a b square is going to be equal to logarithm base c a b square over logarithm base a, it should be base a square b, it should be. Okay, then logarithm base a b square is equal to logarithm base a plus logarithm base a b square. This is the numerator part, because the operation between them times, so this times comes here as a addition. Logarithm base a here, logarithm base a b square here. Again, I'm repeating this part. Beware choosing the base a here, common base a, because in the question see in terms of a. So down logarithm base a square, it's going to be plus logarithm base a b square is going to be b. Here it is a square and b. If I get these powers in front, logarithm base a is equal to 1. So 1 plus 2 times logarithm base a b over, here in this expression, 2 times logarithm base a plus logarithm base a b, it is given, it is c. So here ab is going to be equal to c, 1 plus 2c over 2 plus c is going to be the answer. Okay, if we solve the second one, logarithm base a cube b square ab 4 is going to be equal to logarithm base ab 4 over logarithm base a cube over b square. Here there is a multiplication, here there is a division. So this multiplication is going to affect logarithm base a plus logarithm base a b to the power of 4 over logarithm base a cube plus there is a division, that's why it's going to be minus logarithm base a b square, it's going to be, and it's going to be equal to logarithm base a is equal to 1 plus 4 times logarithm base a b over 3 times logarithm base a minus 2 logarithm base a b, it's going to be. Here logarithm base ab is equal to c and logarithm base a is equal to 1. That's why it's going to be equal to 1 plus 1 is going to be 1 plus 4 times this term ab, here it is written again, and it is equal to c over 3 times 1 is equal to 3 minus 2 times c, going to be